We're starting with our target. I can compare and contrast three types of nuclear particles in terms of definition, strength, and relative mass. So this is going to start our little nuclear learning target. So you need to pause the video and copy down this chart. These are the three radioactive particles that we're going to be using: alpha, beta, and gamma. So an alpha particle is a helium nucleus. Now, from time to time, you may actually see this written a little bit differently. Sorry about that. Let me get the right color pen. You will also see helium written this way, with the 4 is the mass number and 2 is the protons, or the atomic number. So it's 2 protons, 2 neutrons. It does have a positive charge, and the alpha particles are the weakest. The beta particles are high-speed electrons that are emitted from the nucleus at the time of creation. So what happens is they're created in the nucleus. They can't stay there because electrons don't hang out in the nucleus. So they are ejected, and they are ejected with such an energy that we call them radioactive. So because it's an electron, it has a -1 charge, and it's weak, a little bit stronger than alpha, but still fairly weak. Now, gamma rays, I really should, instead of saying particles, this should be called a gamma ray. It's a wave, a high energy X-ray. And these are very, very strong. These are the ones that cause cancer, and they also help cure cancer. They're what's also used in radiation treatment. So make sure you know all of these things about your radioactive particles. Our next learning target for our nuclear section: I can complete and balance nuclear equations. So a nuclear equation, we need to make sure that we know our symbol for our isotope is written this way, with the mass number on top and the atomic number on the bottom. So this is a review from the isotopes that we have already learned about. So remember, your atomic number is your protons, mass numbers, protons and neutrons. Rearrange that number of neutrons as mass number minus atomic number. So this is what we call alpha decay. So what happens here is you have a radioactive particle, in this case radium-226, and it ejects an alpha particle. And so radon is formed when that alpha particle is ejected. So we can write this in symbols. If we write our symbols for our 86 radium, all right, so now we have 222 over, I'm sorry, that's an 88. Sorry about that. You know what? Let's just fix that. Nope, wrong pen. Okay. Wrong color. Sorry. Okay. So that's radon plus our alpha particle. So if you can see this, 4 plus 222 gives me 226. 2 plus 86 gives me 88. So remember that your 88 tells you it's radium, 86 tells me it's radon, 2 tells me it's helium. So make sure you keep those straight. So you may see a question that looks like this: what element is formed when polonium-214 undergoes alpha decay? We want atomic number and mass number for the element. So you start the same way we were just writing those symbols, with your polonium. All right, now if it's alpha decay, that means that you have your alpha particle, that helium nucleus. So the alpha particle is given off, so we need to figure out what is left. So what plus 4 gives me 214? Well, that's 210. What plus 2 gives me 84? That's 82, and then we use the 82 to tell me that that is lead. So lead 210 is the isotope that's formed when polonium undergoes alpha decay. You're also going to see beta decay. So remember, beta particle is an electron. So it's not going to affect the mass. So 0 plus 131 is 131, but it will affect the number of protons. All right, so -1 plus 54 gives me 53. So if we look at an example problem for beta decay, what element is formed when iron-60 undergoes beta decay? So if we start with our iron isotope, all right, remember our beta particle. Now you'll see beta, you'll see it can be written as an E, or it can be written as a regular B. All of those mean the same thing. Alright, so what plus 0 equals 60? Of course, that is 60. What plus minus 1 gives me 26? Well, that's 27, and so this is cobalt. Remember, 27 tells me that I have cobalt. Electron capture is where you capture an electron. You're not going to have to do any of these. I just wanted you to see how that affects your atomic number. So it takes away a proton to give us krypton in this case. Positron emission. A positron is a positively charged particle that's the size of an electron. And you can see that that also affects your atomic number, but you won't be tested on either one of those. Alright, so if you have a problem like this, where you have cobalt 60 is changing into manganese 56, what type of emission is this? Well, what plus 56 gives me 60? That would be 4. What plus 25 gives me 27? That would be 2. So this is a helium nucleus, so that tells me that cobalt underwent alpha decay to form manganese 56.